This is Lesson 2, which covers the terminology, core components, and high-level implementation requirements of Site Recovery Manager. At the end of this lesson, you will be able to list the key components of a Site Recovery Manager solution, compare and contrast the replication mechanisms available with Site Recovery Manager, describe how to achieve the desired outcome, test or failover for each use case using Site Recovery Manager, describe the key new features in Site Recovery Manager. As described in Lesson 1, there are always two sites required in Site Recovery Manager, a protected site and a recovery site. Because these designations are relative to a specific virtual machine, it is possible to do bidirectional replication and failover between two different data centers for different virtual machines. Other replication topologies, such as many sites replicating to a central site, are also possible. Each site requires its own copy of vCenter and Site Recovery Manager, as well as one or more ESXi servers. There are two replication mechanisms in Site Recovery Manager, namely vSphere replication, a native feature of vSphere, and storage array-based replication, which is based on the native replication capabilities of third-party array vendors. vSphere replication requires at least one replication virtual appliance on each site, while array-based replication requires one or more storage replication adapters, SRA, on each site. Both options and their components and requirements will be discussed in more detail later in this lesson. Before looking at the details of vSphere replication and array-based replication, let's begin with a high-level overview of each. vSphere replication is a proprietary technology developed by VMware specifically for virtual machine replication, with or without Site Recovery Manager. It is included with vSphere 5.0 and later, and can be used standalone in vSphere 5.1 and later. It is a manual process for configuration, maintenance, and failover without the automation provided by Site Recovery Manager. It works with any kind of storage, and the source and destination copies can reside on different kinds of storage if desired. Array-based replication, on the other hand, works using the replication capabilities of VMware's storage partners, such as those shown here. They offer higher performance options and potentially lower RPOs, some even offering synchronous replication for virtually no data loss. Because the replication is being provided by an array vendor, the storage must typically match or be very similar on both sides. Let's look more at the capabilities and benefits of vSphere replication. It is important to note that the replication itself to and from the vSphere servers takes place at the hypervisor VM kernel level, though virtual appliances work in conjunction with vSphere to handle and manage the process, including replication between sites. When specifying the RPO recovery point objective, you can specify a value from 5 minutes, the most aggressive option with the least data loss, to 24 hours, the least aggressive option with the most possible data loss. To utilize an RPO of 5 minutes, you need to use vSphere Replication 6.1 or later in conjunction with Virtual SAN. Otherwise, the minimum RPO is still 15 minutes. In addition, vSphere replication in vSphere 5.5 and later supports multiple point in time (MPIT) recovery, enabling you to restore to any of up to 24 previous points in time. This is achieved by specifying the number of points per day to save and the number of days to retain those daily snapshots, and is separate from the number of replicas required by the RPO. With regard to network utilization, after the initial replication, every replication contains only the changes since the last replication to minimize the time and bandwidth required to synchronize that data. Now let's look at the technical details of vSphere replication. As previously mentioned, replication is per virtual machine. However, it can be even more granular because you can specify specific disks to replicate and others you wish to not replicate, like temporary disks. For the initial replication, you can replicate the virtual machine over the network. If you estimate that replication over the network would take too long or consume too much bandwidth, you can restore a backup or copy the files manually from other media to create the virtual machine on the recovery site. vSphere replication will automatically figure out the differences and only replicate those changes since the initial replication. For every replication after the initial replication, it is always consistent to all of the disks that are replicated, meaning that either all disks get copied successfully or nothing goes. The changes made by the virtual machine between each replication are tracked at the VM kernel level and are replicated automatically without involving snapshots, though reverting to a particular MPIT replica does use Snapshot Manager. Finally, vSphere replication works with Volume Shadow Copy Service, VSS, in Windows, allowing apps to be quiesced to enable application copies of data to be replicated. Now let's discuss array-based application. For array-based replication to work correctly with Site Recovery Manager needs to be able to communicate with and control the storage array, rather than hard code how to do so for each partner, which is not very scalable or maintainable. VMware created the concept of a storage replication adapter. A storage replication adapter interfaces with common interfaces within Site Recovery Manager and is created by each storage vendor to integrate with their own management interface for their specific array. So what does the storage replication adapter do? It is responsible for discovering the available arrays, determining which LUNs are being replicated between them, and then implementing the specific commands needed to make storage visible for every test or recovery operation. It is also responsible for removing it from the recovery site when a test completes. The storage replication adapter is also used to reverse the replication direction after a failover and to force the last synchronization before a planned failover. Site Recovery Manager uses specific storage replication adapters when using stretched storage, which is discussed later. Existing SRAs with no stretched storage support will continue to work as is with Site Recovery Manager 6.1. Ensure you refer to the Site Recovery Manager compatibility matrix for a list of all certified array-based replication partners. A virtual machine needs to be complete. In other words, to be useful after replication, the entire virtual machine needs to be complete. Likewise, the data store must also be complete. In other words, include all of the LUNs that make it up. This leads us to the concept of data store and protection groups. A data store group, at its simplest, is all of the LUNs that make it up, as shown in the diagram in data store groups 1 and 2. But that isn't enough. If a virtual machine has disks on multiple data stores, then all those data stores must be treated as part of the same replication unit to ensure all of the components of the virtual machine get properly replicated, as shown in Data Store Group 3, because the virtual machine in Protection Group 3 spanned 2 data stores. Protection groups are groups of virtual machines that will fail over as a unit. It is the smallest unit of failover selectable. In our example, Protection Group 1 is for email servers, 2 is for SQL servers, and 3 is for the SharePoint server. Recovery plans, as noted previously, apply to both forms of replication and constitute one or more protection groups that will fail over together. In our example, Recovery Plan 1 will fail over just the email servers, determined to be a high priority that can't tolerate longer-lasting outages, while Plan 2 is for the entire site with all of the protected groups defined. These concepts, data store and protection groups, are only relevant to array-based replication. For vSphere replication, only recovery plans are needed, of the components described here. Site Recovery Manager 6.1 supports using cross vCenter vMotion in combination with stretched storage, thereby combining the benefits of Site Recovery Manager with the advantages of stretched storage. The integration of stretched storage with Site Recovery Manager 6.1, with the ability to orchestrate the live migration of workloads with enhanced integration with VMware NSX, allows you to achieve what was previously only possible with vSphere Metro storage clusters, specifically planned maintenance downtime avoidance. Orchestrated cross-site vMotion and recovery plans allow for workload migration transparent to app owners or end users. Zero downtime disaster avoidance. Utilizing the ability to live migrate workloads using cross-site vMotion and the planned migration workflow in Site Recovery Manager 6.1, you can avoid downtime instead of recovering from it. By adding stretched storage to Site Recovery Manager, recovery time is reduced. In the case of a disaster, recovery happens more quickly, either because workloads are able to be live migrated, making them available without interruption, or if not, because stretched storage architecture presents the same storage to both sites and utilizes synchronous replication. This makes getting virtual machines registered and powered up when required much faster. When using cross vCenter vMotion, providing zero downtime disaster avoidance and faster recovery is possible, as well as continuing to provide management resiliency, non-disruptive testing, and complete disaster recovery plan orchestration. Site Recovery Manager 6.1 adds a new type of protection group, storage policy-based protection groups. Storage policy-based protection groups use vSphere tags in combination with vSphere storage policy-based management to enable automated policy-based protection for virtual machines. Storage policy-based management enables vSphere administrators to automate the provisioning and management of virtual machines' storage to meet requirements like performance, availability, and protection. vSphere tags can attach metadata to vSphere inventory, in this case, data stores. Data stores make these objects more sortable and searchable, allowing them to associate with storage policies. Tags and storage policy-based management are used together with storage policy-based protection groups. A tag is created and associated with all the data stores in each desired protection group. A tag-based storage policy is created for each protection group utilizing the tag. A storage policy-based protection group is created and associated with the storage policy. When any virtual machine, new or existing, is associated with that policy and placed on the replicated data store, Site Recovery Manager protection is automatic. If a virtual machine is disassociated from that policy and or moved off the data store, it is automatically unprotected. The same happens for data stores and the virtual machines on them. Leveraging storage profiles to identify protected resources saves time and reduces cost and complexity by eliminating the previously manual operations required to protect and unprotect virtual machines, and to add and remove data stores from protection groups. Site Recovery Manager 6.1 adds a new type of protection group, storage policy-based protection groups. Storage policy-based protection groups use vSphere tags in combination with vSphere storage policy-based management to enable automated policy-based protection for virtual machines. Storage policy-based management enables vSphere administrators to automate the provisioning and management of virtual machines' storage to meet requirements like performance, availability, and protection. vSphere tags can attach metadata to vSphere inventory, in this case, data stores. Data stores make these objects more sortable and searchable, allowing them to associate with storage policies. Tags and storage policy-based management are used together with storage policy-based protection groups. A tag is created and associated with all the data stores in each desired protection group. A tag-based storage policy is created for each protection group utilizing the tag. A storage policy-based protection group is created and associated with the storage policy. When any virtual machine, new or existing, is associated with that policy and placed on the replicated data store, Site Recovery Manager protection is automatic. If a virtual machine is disassociated from that policy and/or moved off the data store, it is automatically unprotected. The same happens for data stores and the virtual machines on them. Leveraging storage profiles to identify protected resources saves time and reduces cost and complexity by eliminating the previously manual operations required to protect and unprotect virtual machines, and to add and remove data stores from protection groups. Storage Policy Protection Groups, SPPGs, enable the automatic protection of virtual machines that are associated with a storage policy. When you create storage policy protection groups, you must first create storage policies and ensure that your environment meets certain prerequisites. Create virtual machine storage policies in vCenter Server. Create a storage profile in vCenter Server. Create tags and assign them to data stores. Create virtual machine storage policies. Associate virtual machines with a storage policy. You must also configure network mappings. However, if your virtual machines are connected to port groups that are backed by NSX 6.2 universal logical switches, discussed later in the course, Site Recovery Manager 6.1 will automatically recognize this and not require manual network mapping between the protected and recovery locations. SPPGs support only array-based replication. vSphere replication is supported only through legacy VM-based protection groups. Storage policy protection groups attempt to protect virtual machines associated with their storage profiles only during profile association and server startup. The screenshot shown here shows the way recovery plans look in the web client. The left pane shows a list of all the recovery plans that have been defined. They can be based on department or function or any other way you choose to group them, and any virtual machine can be in any number of recovery plans. The actions that are possible for a recovery plan will vary depending on the current status of the recovery plan. For example, in the screenshot, the recovery plan is executed, so it can't be run again while it is still running, but it could be canceled. We'll discuss more on the key actions later in this course. If a recovery plan is currently running, you'll see an overall % complete status near the top of the window. Detailed step-by-step information, including status and start and end times, are listed below the summary information. Now that we have covered the various components at a high level, let's look at the technical requirements of each when using Site Recovery Manager 6.1. vCenter must be 6.0 Update 1 or later with vSphere 5.0 or later servers at each site. Site Recovery Manager requires a 64-bit Windows OS as well as a database to keep all of its configuration information. This database can be an existing SQL or Oracle database, which can be on the same database server, but must be a different database from any other purpose. You can also use the embedded vPostgres database to avoid the cost and complexity of an external database. If array-based replication is used, the array must have snapshot or clone technology licensed to perform test failovers, and a replication mechanism for all use cases in addition to the appropriate storage replication adapter. If vSphere replication is used, a vSphere replication appliance must be installed on each site. Let's return to the use cases previously described in Lesson 1 and discuss how to accomplish the stated objective of each use case in the user interface. Let's say you want to run a test failover for update or patch testing, or just to confirm that the procedure works as expected. On the recovery site, simply choose to run a test. A wizard pops up explaining what will happen and summarizing the protected and recovery sites, the number of virtual machines involved, and so on. Optionally, recent changes can also be replicated before the test begins to ensure all the latest data and patches are there at the start of the test. Importantly, Site Recovery Manager does not disrupt operations at the protected site. Click the Finish button and the test will commence. It is that easy to run a test failover. The next use case is a planned migration. This may be a preemptive migration for a hurricane or flood, or for a data center migration, as described in Lesson 1. The process is the same in both cases. This option assumes that both source and destination sites are online and can communicate with each other. You choose to run the migration in recovery mode to initiate a failover instead of a test, and then, as shown in here, you select Planned Migration. This will cleanly shut down all the virtual machines on the protected site, perform one last replication of data, and then bring them up on the recovery site. If you are using Site Recovery Manager with a storage array that supports stretched storage, you have the option to enable the migration of eligible virtual machines using Cross vCenter vMotion. Note that if any errors are encountered, the process will stop allowing you to fix the error to ensure a consistent, clean failover. The planned migration can then be run again and will only execute steps that have not been completed successfully. The last use case is an unplanned migration. This option is used when an unforeseen disaster strikes, such as an earthquake or a power failure, as also described in Lesson 1. This option will work if the source site is offline, which is often the case when a disaster strikes. You choose to run the migration in recovery mode to initiate a failover instead of a test, and then, as shown here, you select Disaster Recovery. This will attempt to shut down the protected virtual machines and complete one last replication of data. However, it will continue with the last replicated data if that fails, as is often the case. It will then bring up the virtual machines on the recovery site. Note that if any errors are encountered, the process will continue regardless, giving you the best recovery possible under the circumstances. It is possible by checking the Forced Recovery checkbox to run this workflow only on the recovery side, assuming the source site is completely inaccessible and/or destroyed. In this scenario, some additional work may be required to get everything working when the original site is brought back online. One of the features of Site Recovery Manager is that dependencies can be set between virtual machines so that they come online in the correct order, with any prerequisite virtual machines being online first. This is accomplished by having up to 5 groups as shown in this example, as well as optional dependencies within a group. Groups are processed in order, with all of the virtual machines in Group 1 starting before moving on to Group 2, and so on. Within any of the groups, virtual machines can start in any random order, or dependencies can be set such that one virtual machine is online before another is started if necessary. In the example, the master database is brought online first in Group 1, followed by another database server and an Exchange server in parallel in Group 2. Next, App Server 1 is brought online, followed by App Server 2 in Group 3. Following that, both Apache servers and the Mail Sync server are brought online in Group 4, and the process concludes with all of the desktops in any order in Group 5. Note that it is not required to use all the groups. Any number of groups can be used as needed, up to the 5 possible. Self-service policy-based provisioning and a new vRealize Orchestrator plugin enables simpler tenant-driven provisioning of predefined DR protection tiers to new virtual machines via blueprints in vRealize automation when using array-based replication. From an architecture perspective, Site Recovery Manager must use array-based replication, not vSphere replication, and vRealize automation management must span both sites. Also note that Site Recovery Manager can also be managed via PowerCLI. As for the actual self-service capabilities, vRealize automation enables self-service using blueprints, which define the Site Recovery Manager configuration, virtual machine location, etc., desired when a user deploys the blueprint to create a virtual machine. The user can even specify which Site Recovery Manager group, essentially a priority, the virtual machine will be started in, as described earlier. Why is this a big deal? This enables end users to know that the workloads they create are automatically protected from disaster. This also reduces the complexity and workload for infrastructure administrators because they don't need to manually monitor and protect new virtual machines as they are created. Enhanced workflows and integration with the vSphere web client streamlines Site Recovery Manager administration in the next generation user interface of VMware solutions. A big change for administrators is that the vSphere client, sometimes called the C# client based on the language used to create it, is no longer required or even supported. In all previous versions, it was the only supported client. By moving to the vSphere web client, Site Recovery Manager becomes a part of the family of products managed via a single interface, providing a single user interface to manage the environment. In addition to the basic user interface platform change, the interface also simplifies storage policy mapping when using array-based replication and makes bidirectional resource mapping much simpler. More information is provided in the interface, and a workflow guide to setting up Site Recovery Manager is also provided. Now let's look at the new and improved features in Site Recovery Manager 6.1 compared to the previous version, 6.0. Some of these features have been mentioned previously, and several will be discussed in more detail in the following screens. Site Recovery Manager 6.1 enables policy-based management through a new type of protection group that use vSphere storage profiles to identify protected data stores and automate the process of protecting and unprotecting virtual machines and adding and removing data stores from protection groups. Site Recovery Manager 6.1 also integrates with VMware NSX 6.2. So you can now use network virtualization to simplify the creation and execution of recovery plans and accelerate recovery time. Leveraging NSX, SRM now allows you to automatically map network resources across the two sites. And after failover, network and security policies are automatically preserved on recovered virtual machines. Not having to re-IP recovered VMs can further reduce recovery time. Finally, Site Recovery Manager 6.1 can deliver zero downtime application mobility by orchestrating cross vCenter vMotion operations using recovery plans. This enables disaster avoidance and data center migrations without downtime. Site Recovery Manager supports this capability when using a metro distance stretched storage solution from certified third-party vendors. For stretched storage users, this integration offers the benefits of Site Recovery Manager, such as non-disruptive testing and orchestrated virtual machine recovery, which are not possible in the traditional vSphere Metro Storage Cluster implementation. Networking is typically one of the more complex and cumbersome aspects of a disaster recovery plan. It can be quite challenging to ensure that the proper networks, firewall rules, and routing are configured correctly and are available. Making an isolated test network with all the same capabilities can be even more so. Additionally, solutions like Cross vCenter vMotion require a stretched Layer 2 network, which can create even more difficulty. NSX 6.2 supports creating universal logical switches, which allow for the creation of Layer 2 networks that span vCenter boundaries. This means that when utilizing universal logical switches with NSX, there will be a virtual port group at both the protected and recovery site that connect to the same Layer 2 network. When virtual machines are connected to port groups that are backed by universal logical switches, Site Recovery Manager 6.1 will automatically recognize this and not require manual network mapping between the protected and recovery locations. Site Recovery Manager intelligently understands that it is logically the same network on both sites and thereby automatically links the protected and recovery networks. The ability to create a network that spans vCenter boundaries and creates a cross-site Layer 2 network means that after failover, it is no longer necessary to reconfigure IP addresses. This can reduce recovery time. Security policies, such as security groups, firewall settings, and edge configurations, are also preserved on recovered virtual machines, further decreasing the need for manual configurations post-recovery. NSX 6.2 also supports the synchronization of firewall rules, as well as routing information and configuration. These capabilities make it easy to ensure that the network configurations of production and recovery sites stay in sync, while also making it easier to create an isolated duplicate of the recovery site network in order to non-disruptively test recovery plans. To fully utilize stretched storage and the vMotion of protected virtual machines, stretched Layer 2 network connectivity between sites must be in place, as it isn't possible to non-disruptively change the IP address of a running virtual machine. This feature is only available when using storage policy protection groups and is only available in VMware Site Recovery Manager 6.1 and later, and VMware NSX 6.2 and later. Site Recovery Manager supports active stretched storage between protected and recovery sites by using Cross vCenter Server vMotion to perform planned migrations, eliminating service downtime. Disaster recovery and test recovery continue to use the existing LUN-based recovery functionality. Planned migration orchestrated vMotion provides the ability to proactively migrate virtual machines from a vCenter server located in one site to another vCenter server in another site in order to carry out maintenance on one site or to mitigate any possible disaster without incurring any downtime for the virtual machine application workload. Planned migration orchestrated vMotion is only available when using stretched storage, storage policy protection groups, and vCenter servers in enhanced linked mode with stretched networks, with the assumption that the IP addresses of the virtual machines don't change. vMotion in planned migration mode can be overridden for individual virtual machines or for the recovery plan. For example, if vMotion would take too long to complete. Along with virtual machines that are not vMotion compatible and part of the recovery plan, they will be shut down and restarted on the recovery site. As the virtual machine resides on stretched storage, the recovery of the virtual machine will be quicker as the volume is already visible at the recovery site. Now that you know what Site Recovery Manager is and all of its benefits, you need to know how to license the software. Site Recovery Manager is available as a standalone product or as part of the vCloud Suite bundle. If you purchase it as a standalone product, there are two editions to choose from, Standard and Enterprise, both of which are licensed per protected virtual machine. Site Recovery Manager Standard is limited to a maximum of 75 protected virtual machines per site, while Enterprise has no limits other than the Site Recovery Manager limits. Both are sold in packs of 25 protected virtual machines. Site Recovery Manager Enterprise contains all the new features available in Site Recovery Manager 6.1. If you want Site Recovery Manager as part of a bundle, you need to purchase the vCloud Suite Enterprise bundle. The lower editions don't include Site Recovery Manager. This bundle includes vRealize Automation, vRealize Operations, vRealize Business, and vSphere Enterprise Plus. It is licensed per CPU, that is, per socket of the vSphere server, and can protect an unlimited number of virtual machines, again, subject only to Site Recovery Manager limits. It's time for another knowledge check. Which of the following Site Recovery Manager components are required for storage-based replication? Select two options, then click Submit. This is the end of Lesson 2. You are now able to list the key components of a Site Recovery Manager solution. Compare and contrast the replication mechanisms available with Site Recovery Manager. Describe how to achieve the desired outcome, test or failover for each use case using Site Recovery Manager. Explain the possible dependencies between virtual machines during a failover. Describe the key new features in Site Recovery Manager 6.1. List the available packaging options for Site Recovery Manager. Thanks for taking the VMware Site Recovery Manager Fundamentals Course 6.1. You are now able to discuss the challenges of traditional disaster recovery, DR, as well as the capabilities and business use cases of Site Recovery Manager. Identify the terminology, core components, and high-level implementation requirements of Site Recovery Manager 6.1, including storage dependencies.